In this part of 1.6, we're going to look at radical equations. We're going to need to use the power property. The power property says if we have an equation like P equals Q, then we can take and raise both sides to the same exponent. This will be important whenever we're trying to get rid of our radicals. Here are the steps we're going to use to solve an equation with a radical. First of all, we want to isolate the radical on one side of the equation. Second, we're going to raise each side of the equation to a power that is the same as the index of the radical. So for example, if we have the cube root of x equals 5, then we're going to raise each side to the third power because that's the same as our index on our radical. By doing that, we will cancel out our cube root because a cube root and a cube are inverse operations and they cancel each other. We may have to repeat steps 1 and 2 if we still have a radical going on. Step 3, solve the resulting equation, and step 4, check our answer. So for this first equation, we have our radical on the left side with an x term. So step 1, isolate the radical. We're going to move our radical over by adding it. Next, we're going to raise each side to the power of 2. And the reason is because our index for our square root is a 2. Anytime we don't have an index written, like in this example, we know that it's 2. Now notice that the equation that we have left is a quadratic because there's an x squared term. So we're actually going to need to factor this. In order to factor, move the 2x and the 15 over to the same side as the x squared and set up your x, where we have a times c in the top, so negative 15, and b in the bottom, which is 2. Now the two numbers that multiply to negative 15 and add to 2 are 5 and negative 3. So now we'll replace our 2x term with 5x minus 3x and factor by grouping. To solve, we need to set each of those equal to 0 and solve. We always need to make sure that we're checking our answers because sometimes we find answers that are called extraneous. Whenever we solve the equation, it looks like they might be an answer, but when we go back to check, we find out that it's not actually an answer that works. So we're just going to start by taking our negative 5 and plugging it back into the equation and seeing if we get a true statement or not. So here you see we've got negative 5 minus square root of 5 equals 0. I know that that's not true, so I know that negative 5 is not one of my answers. Now we'll check x equals 3. We get 3 minus 3 equals 0, which is true, so my only answer for this problem is x equals 3. In this next example, we have two radicals, but if I move one to the other side, I still have something going on with it, so I can't isolate both radicals. So what I'm going to do is I'm going to move my square root of x plus 1 over to the right side. So I'm just going to focus on isolating one of my radicals, in this case the 2x plus 3 in the radical. So now I can raise both sides to the second power so that I cancel my radical out around the 2x plus 3. But what I've got on the right side is a binomial, so square root of x plus 1 and then plus 1 squared. So we're going to either need to FOIL or use our box method or use our special case that we know from earlier. I'm going to do the box method so we can kind of see it worked out. So start by multiplying your square root of x plus 1 times square root of x plus 1. Anytime we multiply that by itself, it's like squaring that. So our our radical cancels out. We just get x plus 1. 1 times the radical each time is just x plus square root of x plus 1. And then 1 times 1, we just get 1. Okay, so now let's look inside of the box here. I have a few like terms. First of all, let me get my highlighter here. First of all, x is a term just by itself, so we're going to put x by itself. And then we're going to have these ones that we can combine to make 2. So x plus 2 is what we have so far. These two terms look the same, so I'm going to add them together and I get 2 square root of x plus 1. Now we're going to repeat our steps 1 and 2 again since we have a radical still. So we're going to isolate our radical. It's okay to leave that 2 in front of the radical with it. Now we're going to square both sides so that we can cancel out our radical. Again, we've got a binomial. I'm going to do x plus 1 squared up here in the top using box method. Now make sure that you square the 2 and you square x plus 1. So that gives us 4 times x plus 1. I'm going to distribute the 4. And then notice that I have a quadratic that's left still. So I'm going to move everything to the left side so that it's on the same side as my positive x squared. And then I'm going to factor and solve. Now don't forget to check. We always need to check our answers here. So take 3, plug it back into the equation. And we get a true statement. And now we'll plug in -1. And again, we get a true statement. So this time, both x equals 3 and -1 is our answer. In our next example, we have cube roots going on. So eventually, we'll be raising both sides to the 3rd power, since that is the inverse operation of a cube root. But first, we need to isolate our radicals. So we're going to move the cube root of x over to the right side. And now we're going to raise each side to the 3rd power. Again, that's because we have cube roots in this example. We've got a quadratic here, so I'm going to move my x over so that I can factor my quadratic. Set my x up. I have a times c in the top, b in the bottom. And we're going to factor by grouping. Once we've factored, we're going to set each of our factors equal to 0 and solve for x. Again, we're going to check our answers here. So first I'm going to plug in 1/4 or 0.25 into the equation. I chose to do it in decimal form just to make it easier for me in the calculator. And I'm just going to simplify the inside of that first radical, and I get 0.25. So this is a true statement. And now to check x equals 1, plug 1 in. Simplify our left radical, and we find that this is also a true statement. So our answer here is x equals 1/4 and 1. In this next example, I don't have any radicals necessarily, but I do have a fraction exponent, which we could always change to a radical. The easier way to do this, though, is to raise each side to something that when I multiply it with 3/5, I get 1. In this case, it's just going to be the inverse of 3/5, which is 5/3. So I'm going to raise each side to the 5/3. Again, I'm doing this because when I multiply 3/5 times 5/3, which is what we do whenever we have a power raised to another power, I'm going to get 1. So therefore, we get x by itself. In the end, we get x equals 243. You can check this by plugging in 243 to the 3/5 in your calculator, and you get 27. This problem is similar to our last one. So we're going to raise each side to the 3/2 because that will cancel out our 2/3 exponent. Now, anytime that we have an even root that we're raising a power to here, so in this case our denominator was a 2, so that would have been an even root, we need to use a plus minus for the number that we get. So 16 to the 3/2 is going to be plus minus 64. So now I'm going to split this into two equations, x minus 4 equals 64, and x minus 4 equals negative 64, and solve. If we plug 68 back into our equation and check it, we get a true statement. And again, if we plug in negative 60, we also get a true statement.